Hey guys, today we'll be learning on how to find the lowest common multiple or LCM of two or more numbers. So what is the lowest common multiple? The lowest common multiple, it's easier to explain this if you know what common multiples are. Common multiples are multiples which have the same value, multiples of two or more numbers which have the same value. Let's take 1 and 2. All numbers are multiples of 1. And the first multiple of 2 is 2. The second multiple of 1 is 2. They both of them meet at 2, 4, 6, 8. Both of their multiples. And their lowest common multiple will be 2 because that's the smallest number, the smallest common multiple. So, let's see how to find the least common multiple of two or more numbers in this video. We can do this by two ways: the listing method and prime factorization. The listing method takes a bit more time than the prime factorization method, but it's a lot more easier. The teachers in your school will probably ask you to do the prime factorization method in your exams. So the listing method is pretty simple. Let's take the numbers 6 and 14. Let's list the multiples of 6. Let's say like the first 10 because 6 a pretty small number and 14 is like double of it. So the place at which they meet has to be a bit high. So 6, let's say the first 10 multiples of 6. 6, 12, 18, 24, 30, 36, 42, 40, 48, 54 and 60. And for 14, let's say the first 5. 14, 28, 42, 56 and 70. So let's see the common multiples. 14 is here, but 14 is not in 6 multiples. 28, no. 42, yeah, 42 means. That's the lowest common multiple. See, that was pretty simple, but that takes a lot of time. Probably if I stopped with 30 and then I write this and I figure out that, oh no, I have to write more multiples. So this doesn't work for bigger numbers, but it does do good for smaller numbers. So in this case, the LCM is 40. Now let's take the same 6 and 14 in prime factorization. In prime factorization, we'll do short division, but with only prime factors. It is our choice to choose the dividend. So, let's take 6 and 14, and in this case, both of them are divisible by a prime number, which is 2. Because it's prime factorization, we'll only use prime numbers to divide. So let's take 2. I hope you know short division. In this case, we don't have reminders and all, so it should be pretty easy. So let's take 2. 2 is divisible by 6, which is 3, and 2 by 14, 7. We don't have to do more than this because all 3 of them are prime numbers. Anyway, the next step we'll do is probably 3 and then 1 and 7 and 1. We'll get 2, 3, 7, 1, 1. It's the same thing because anyway we are going to multiply. 2 into 3 into 7 into 1 into 1 is nothing but 2 into 3 into 7. So let's stop here because LCM is equal to this. 2 into 3 into 7 is nothing but 42. So LCM 42. In this case, this was a lot faster, and for bigger numbers this is easier. But for smaller numbers you can use that because it's a lot simpler. You don't have to do this short division, show the multiplication and write the answer. So that's pretty simple for small numbers. So let's look at three numbers. First we'll look at listing. Let's take 3 17 and 24. 3, 17 and 24. Because 24 is such a large number, we'll have to write lots of multiples. So listing is out of the view. We can't use it because 3 into 10 is equal to 30. We have to write 10 multiples. So that's a very long process. So let's look at prime factorization itself. I'll do it on the other side of the board. So let's take 3, 17 and 24. First we'll do by 3. In this case, 3 is divisible by 3. 17 is not. So we just carry down 17. You don't do anything of it. You don't write 5 and take 2 remainder, carry it over, nothing. Because all these three numbers are not related to each other. So, and then again 8. Now we can do by 2 because 8 is divisible by 2. We keep one as such, 17 and 4. Again 2. 1, 17, 2. After this, I don't think we have to factorize more because all we've got here is prime numbers and a 1. So 3 is prime, 2 is prime, 2 is prime. Ignore the 1. 17 is prime and 2 is again prime. So the answer in this case will be 3 into 2 into 2 into 17 into 2. Let's do the into 2's first. So 2 into 2, 4 into 2, 8 because we can do multiplication in any order. And then 8 into 3, 24. And then we have 24 into 17, which is in this case 28, 2, 16, 0 to 40, 8, 0, 1, 408. So the LCM is 408. So that's a pretty big number. And all we see is we could have just done multiplication into this. So why didn't we do that? How can we use it? So here's a short trick that you can use in your objective papers or spot tests probably. So if you are given a prime number and some other number, say 5 and 14. If we do prime factorization, we are just going to get 5 into 2 into 7, which is nothing but 5 into 14, right? Why do we have to do prime factorization? So if you see a prime number, I am talking about two numbers now. If you see a prime number, just multiply them. That's going to give you your LCM 70 in this case. So then in this case 3, 17 are prime numbers, right? So 24 into 17 into 3. No, because 3 can go into 24. 3 into 8 is 24. So we can find the LCM of 3 and 24, which is 24. I hope you understand that. 3 meets at 24 because it's a factor of 24. So we do 3 into 17. But if it was 5, 17 and 24, we would have got an answer like so big, which would have been 120 into 17, which would have been 0, 4, 1, 8 plus 1200, which is like 0, 4, 0, 1, 2040. If it was 5, 17, 24, because 5 doesn't go in 17 or 24. 17 doesn't go in 24. 24 is the largest number. So check that if you have prime numbers. And just multiply. Simple. 5 into 17 into 24 is nothing but 2040. That's your answer. So, you have learned some tricks, you have learned the basic method, learned listings. So, hope you understand how to find the least common multiple. If you have any doubt, post it in the comments. I'll try to look them up and solve them for you. So thank you for watching and hope to see you soon again. Thank you.